So as I said, that is that. So I hope we have been able to understand the GIS software options and the landscape of what defines GIS in entirety. That's what I was trying to explain. Okay, so let's move ahead to the next. Let's go to the next program and see. Now I would like to explain what a coordinate system is. The coordinate system is very, very important too, because once you get a raster image of any location, let's say your institution, and you successfully add it into GIS softwares or QGIS, now what you have just done is basically bringing a raster data into a software platform. What it means is that yes, that image might show you exactly how the structures, the circulation, and everything pertaining your institution is arranged, and it's true because it's an image of where it is taken from. But there's an issue. The issue here is simply that whatsoever design you do on that image by tracing it is not aligning with the actual dimensions on Earth. It means that that image is lacking geographical coordinate system. Now there is a term you must have heard of it. We call it georeferencing. Is very key. We are coming to that. Now the act of assigning geographical coordinate system to a raster image is called georeferencing. After adding your raster image into the GIS, the next step is you must georeference it. That is giving it the actual point, the reference system as it is on Earth, into the software. Okay, I don't know if anybody is understanding what I'm saying, but I'm trying to explain this better. Now, a coordinate system simply means the assignment of the Earth globe with alphanumeric data called gratitudes, and gratitudes are simply latitude and longitude, and other techniques such as zonings to ensure accurate location and positioning of objects or features on the Earth's surface. Yes, that is very key. The coordinate system is very, very important. Though there are platforms which we could query geographical data that we don't need to georeference. We'll come to that. I'll explain it better in the future. I don't want to start saying things that will get us confused now. Those platforms actually have self-georeferencing. What they did is that they categorize the entire Earth into zones, and whatever they do it based on those zones. So those zones, you just need to know your zone, and you just go ahead and query. You demand for it. There are some that you pay, there are some that are free. Then you can download. Once you download, you can easily add it into your GIS platform without necessarily georeferencing it. That is adding a geographical coordinate system into or onto the raster image. Okay, please let's try understanding. I'll be using technical terms. I've explained what raster is deeply. Now we call it the UTM. We have a lot of other types of coordinate systems, but for now I'm going to basically talking about UTM, and the UTM simply stands for Universal Transverse Mercator. Now the UTM is a system for assigning coordinates to location on surface of the Earth. Like the traditional method of latitude and longitude, it is a horizontal position representation, which means it ignores altitude and treats the Earth as a perfect ellipsoid. Now you can go ahead and look at what ellipsoids and geoids are. I don't want us to go deep into those areas. However, it differs from global latitude/longitude in that it divides Earth into 60 zones and projects each to the plane as a basis for its coordinate system. Specifying a location means specifying the zone and the XY coordinate in that plane. Yes, just as what I was explaining earlier on. Now all you need to know is to know when you are setting up your space for your GIS or to start your design, you will need to know which zone you belong to. So I have a zone for Nigeria, the UTM zones for Nigeria. I'm going to show us the image so you'll be able to trace where you belong. And when we come into working with GIS, there will be exercises. You drag the image of your institution, we do reference, we will do the settings, you use your UTM zone from the state you belong, and then we begin work. We are coming to that. Everything is going to be simple. I just want us to understand the nitty-gritty before we dive into that. Now the projection from spheroid to a UTM zone is some parameterization of the transverse Mercator projections. Now I know that most of us have done GIS as courses in advanced institutions, you must have come across what map projections are. Just in case you want to understand more, you can also venture into making your research on what map projections are. UTM is just one method of map projections. We have a whole lot of other methods. This is one of the easiest ones to use. Okay, now most zones in UTM span 6 degrees of longitude and each has a designated central meridian. The scale factor at the central meridian is specified to be 0.996 of true scale for the UTM zones in use. Now don't get confused with all what I'm just trying to reach so that we get the understanding. Now I have the Nigeria falls between 3 zones. We have UTM zones 31 north and 32 and 33 north. Now let's go ahead. Now this the Nigeria UTM projection. You can see your latitude and longitude and you have the zones here. Here is zone 31. These are states found within 31. Although Edo is partly 31 and 30 and 32. We have Ondo, we have Ekiti, Osun and the rest. Any state that is vertically aligned onto WGS 1984 of under UTM zone 32, you use this zone. If you are still fall within zone 32, we are coming to that. Will show us how to do that, like Abuja, Kaduna, Plateau, Benue, Taraba, Kogi, Oyo, Rivers, Cross River, Ebonyi, Anambra, Enugu, Katsina, Kano, Jigawa and the rest of them. We fall under zone 32 and we have only 3 states under zone 33. That is Adamawa, Borno and part of Yobe state. Those are UTM zones that covers those areas. So that's the Nigerian UTM zone projection. It's very important that we know the UTM zones in order for us to understand whatever maps design or whatever work we are doing on GIS. We are actually doing that to scale. We are actually doing that to what is achievable on real time. So each and every work we do has to be geo-referenced. It simply means it has to have a coordinate system. The coordinate system, and it has to align with what is obtainable with the UTM zones. We are coming to that. The GIS software has all those provisions that you can easily enter the necessary settings for your location for you to commence any such work. Okay. So again, it doesn't mean that because I reside in Lagos, that's under zone 31, and maybe there's a project that I have in Borno State, it doesn't mean that I cannot handle that project. Of course, that would be so funny. All you need to know, all the data in all of these states. What it simply means that you can be in Lagos and actually do a work in Borno State. All you need to do is to do the setting for Borno State by using the zone 33 and all that. Alright, so that is that. From here, you can also work as a freelancer in other developed countries if you are a pro in GIS. All you need to do is to know the UTM, the setup of the UTM, and all the projections. That is all. You can work anywhere from the comfort of your home. Okay, so that is that for this class. Now I now say, okay, what are the practical applications of GIS in the built environment? The applications of GIS in the built environment cannot be overstated because it cuts across all spheres of the environment, as it serves as a tool for planning, replanning, sorry for the spelling error, studies, and ultimately takes a decision based on result analyzed on various variants of GIS platform. This includes where you can apply GIS. You can also actually create layout plans, you can create land use plans, you can create land use land cover plans for monitoring, you can do flood simulation, vegetation monitoring, you can create topography plans for man, you can create terrain map, you can actually create 3D models as well. There's what we call axing. That will be a matter of time. Alright, there are a whole lot of other applications of GIS. Now here you can see at my top left, these are layouts. These are all layouts. These are layout plans that were used, that GIS was used to create. You can also have land use maps. This is a terrain maps of a study area called Genta in my state here. You can also develop your site analysis map. You can see them here. This is an image of Eco Atlantic. I'm trying to show some studies about drainage pattern. You can actually do a whole lot of works. So that would be that for with GIS fundamentals. Now please, if you do have a question or comment, you can drop it on the WhatsApp platform. and we get to attend to them judiciously. We also have assignment. You try to do this assignment. So thank you, and catch you on the next one.